Hello and welcome to everyone in Physics Fire. Today we are going to do the second chapter of class 12, that is electrostatic potential and capacitance. As this is also a part of electrostatics, so here also charges is going to be addressed. This chapter also plays a major role, and again big chapter, it's not that small chapter. Minimum 13 to 14 parts it will take to complete this chapter, but comparatively this chapter is little easier than the first chapter. Why? Because electric field, electric forces all are what? Their vector quantities was there, but here potential itself is what? Is scalar. So adding, subtracting, whatever, that it do not, like, there is no need of direction, right? So let's start with the chapter. First we will see, first part of the chapter is electrostatic potential and the second part is capacitance. So first we'll discuss completely about electrostatic potential, second we will see what about capacitance. Let's start with electrostatic potential and capacitance. As the chapter name is electrostatic potential and capacitance, let's do little painting and all, right? So it will look good. Okay, yes, so fine guys, the first topic we are supposed to do here is electrostatic potential difference. As potential, if you will see, we cannot define it individually. Whenever we will say define term potential, then we cannot define it individually. Always we'll have to consider with respect to something. Difference in potential is possible, but potential cannot be defined alone. As in 11th also, if you will see, the same thing we learned there also in electrostatic, in potential energy, potential mgh, there also what? Change in potential is defined. Potential alone is not defined. So here also potential alone is not defined, change in potential is defined. So we will start with the topic is potential difference. Potential difference. If you will say for the sake of definition, then we can say work done per unit charge to bring a charge from infinity, from one point to another point, because difference is there, right? So what is that? Work done per unit charge to bring a charge from one point to another point. Suppose one charge is we are bringing from here to here, from here to here, from point A to B, from A to B. That is known as what? Potential difference. Ultimately, when you will bring a charge, now see one more thing. When you will bring a charge, one thing you will have to assume here, that velocity, not assume, it is there. Kinetic energy should not change of the charge. Kinetic energy should not change. Fine. So work done per unit charge to bring a charge from infinity to from one point to another point is known as what? Potential difference. So we can say, suppose Q naught charge is here at point B, and all the way we are taking it to what? A. Assuming kinetic energy is what? Constant. Assuming what? Kinetic energy is constant. Important. If kinetic energy will change, then everything will change. So remember this. Assuming what? Kinetic energy is what? Change. So we can say VB, right? VA is the final potential. VB is the initial potential. So we are doing some work done by external agent, by the charge, by the test charge. Test charge we learned there, right? Test charge is what? A positive charge and a point charge. Two important points we should know, right? And that we are bringing very slowly, right? Slowly, very slowly, right? Means kinetic energy is constant, that's slow. Fine. So slow, right? So that nothing will change. Fine. Now we will see if potential energy, how we will define now? Potential difference, work done per unit charge, right, to bring a charge from one point to another point is potential difference. Now potential at a point, if you will define potential at a point, Potential at a point, if you will define, then we can say that what? Let's take a charge is at infinity and we are bringing all the way to this point A, right? This Q naught charge is there. So again the same thing, we'll bring it what? Slowly, right? Kinetic energy should not change. So we can say VA minus of what? V infinity is work done by external force to bring a charge from infinity to a point A divided by a charge. That is known as what? This should be outside, right? Okay, I'll make it outside. So we can say yes. So this is the formula of what? Potential at infinity. Acha. In NCRT, no, in any even if you do a single numerical there, it is written, well, you should not laugh on that. It is written in each and every numerical that potential at infinity, assuming potential at infinity is 0. It means 1 point we learn that what? Potential at infinity is what? 0. Every question you will see. Now here how we should define? Work done per unit charge to bring a charge from infinity to a specific point. Work done per unit charge to bring a charge from infinity to a specific point is known as what? Potential at a point, or we can say electrostatic potential. Fine. So that we got. Now a few points we should know. Again, potential, guys, if you will see, is a conservative force. Potential is what? We can say electric force, magnetic force, any field if you will see, all are what? Conservative in nature. So potential, sorry, what I wrote. Potential is conservative in nature. Conservative in nature means, suppose if a charge Q naught you are taking from A to B by this way or by this way or by this way, the work done is going to be what? Suppose this is W1, this is what? W2, this is what? W3. So 1, 2, 3, all are what? Same. Potential is going to be what? Same. So work done in a closed loop is going to be what? 0. We learned, no? We did also, right? Electric field lines cannot form a closed loop because it is conservative in nature. Same thing here also, right? So we can say in all the three parts, work done is going to be what? 0. Now guys, as we have seen that what, if you bring a charge from infinity to a specific point, then we'll get work done is potential is equal to what? W by Q. Let's derive this, how this, what will be the formula that we are going to see now. So electric potential due to a point charge Q. Electric potential due to point charge Q at distance r from it. Now let's derive it. So this charge Q is there. We are bringing a test charge from infinity to this point. Let's take R. All the way we are coming here. Okay, if you'll bring this charge from here infinity to point R, of course let's take point P, you will have to do some work for sure, right? Correct. We know also potential is work done per unit charge. Fine. Now the problem is what? We don't know how much force will act. Guys, when this charge will come here at this point P, Q naught charge will come at point P, then we can say there will be electric force. Of course, that force will be in this direction. F is equal to K Q1 Q2 by R square. Both the charges are of same nature. Pull, right? And we are bringing the charge in this direction. So external force in this direction, right? And external force and what? Electric force in this direction. Both are in opposite direction. That we understood. Very good. Guys, if you bring this charge here, then it will have some force and there is some distance r, right? Let's take this distance as what? r. Okay, the distance is what? R. Second thing, what we can say, distance is r, and then what else? Two charges are there, right? Two charges, that 2 point charges are there. So we can say electric force is going to be Coulomb's law. We can apply K Q naught by r square. Okay, that is the electric force. Fine, guys. One thing again, whenever you will bring a charge from anywhere here, the kinetic energy is going to be what? Constant. It means velocity should not change at anywhere between infinity to point P. There is no change in what? Velocity. So we can consider, we don't know how much force, what is the force. So what we can say, let's take a small element here, dx. At this particular point, we'll find potential. We'll integrate from r to infinite, we'll get answer. Finish. What we will do, what I thought, okay, this point, this we consider this is infinity, and this point is r. In between them, what we consider, we don't know how much force and it will act, right? It can vary in between. So what we did is, a small element we took from here, we'll take dx element, and there is a charge q. In between them there will be some distance, let's consider that is x. Then what we can do, we can find work for this. Work is equal to f dot dx. We'll find work from here, then we'll put in the formula of potential, we'll get answer. Let's see, let's try this. Now we can say in this direction, guys, in opposite direction, there is going to be a force. That force is going to be what? External force, right? And in this direction, what? There will be a force, electric force, right? This force, electrostatic force, right? Okay, let's find external work done. Work done is equal to, work done by external agent is equal to f dot dx, right? F dot dx. Achha, which force is acting? Which is opposing the external force? Electric force. So we can say that force is going to be what? K Q naught by what? Achha, what we are considering here, dx we took, right? What we are considering, distance from here to here, we'll have to consider from here to here distance. So that distance we consider what? X square, dx x square. It is easy. Now force is acting in this direction, displacement is in this direction, but force is in this direction, opposite, 180. See, force, displacement, force, distance, angle, supplementary, right? 180 degree. So we can say cos of 180. Cos of what? 180. Integration of where to where? Infinity to point P. P is what? R. Finish. Right? Now we can say, till here, hope so you guys understood. Now we can say K, Q, whatever the things which is constant, I'll take it out. Dx by x square, right? From where to where? Infinite to R. That is going to be what? Work done by external force. So K, Q naught by what? Dx by x integration is, acha, one more thing, no? Cos 180, right? Cos 180 value is what? Minus of 1. So minus of 1, and then what? Minus of x by what? Infinite to R. Now we will put value of R, right? That much of integration we learned. If you didn't learn, then you can refer the video, basic maths integration I took little there. So K Q naught Q by what? Minus of 1 by R. Infinite is going to be 0. So this minus and this minus is going to be plus. K Q naught by what? R is what? Work done. So potential is what? That is work done by external agent. So potential, guys, change in potential is equal to, what is that? Work done by external agent by the charge, test charge. Work done by external agent is Q naught by R by Q naught. K Q by R. Potential is KQ by R. KQ by what? R. That's it. Got KQ by R. Unit, potential unit. Say work done by charge, right? So work done by charge. So we can say joule per coulomb or volt, right? This two will be the unit of potential. Hope so till here you guys understood, right? See the derivation. This is what we did. So till here you guys, right? then we'll see few numericals based on this. Potential due to a system of charges. Potential due to a system of charges. System of charges, if you will see, suppose at point P is there, and then we can say Q1, Q2, Q3, R1, R2, R3, right? So now distance, right? Okay, as I told you before also that there is no problem with direction, so directly we can add. Okay, net potential at point P is equal to first charge KQ1 by R1 plus KQ2 by R2 plus KQ3 by R3. That is going to be the net potential at point P. Hope so easy, right? Okay, now let's see 2-3 more numericals. Find potential, find V is 0 on the line joining. How I am writing, the problem is what now, I'm supposed to write like this, so the writing is not, anyway my writing is not that good. So find V is 0 on the line joining, two charges, in between two charges, in between two charges. So let's see, these are the charges. Let's take plus 2q and minus 4q, right? In between them you are supposed to find what, the distance is what, 2 meter. Let's take, you are supposed to find, obviously one will be positive, one will be negative, then only potential is going to be what, 0. We learned electric force, when the charges are different, right? Like where is electric force 0? When the charges are different, the nature of the charges are different, then the net force is going to be 0 in between the two charges, in between the line joining of the two charges, and it will be nearby the charge which is having less magnitude. Same thing here also. So we can say now, what we can say, let's consider here, right? This distance we can consider x, right? This distance what we can consider x. Yes, so this distance is what, x. This is going to be what, 2 minus of x. No problem with direction, right? So directly we can say net potential, let's take this point is what, A. Net potential V net is equal to what, 0. So V net is going to be what, V1 plus V2. V1 plus V2 should be equal to what, 0. So now we can say potential due to this, guys, distance charge K 2q by what, x. Acha, K 4q by what, 2 minus of x. Acha, what is the charge nature, minus. Actually it should be plus, but the problem is what, this is minus, is equal to what, 0. K 2q by x minus so take that side, so it is going to be K 4q by what, 2 minus of x. So kq cancel out, 2 4 2, so 2x is equal to 2 minus of x. Now it will come this side, so it is going to be 3x is equal to 2. 3x is equal to 2, x is equal to 2 by 3. That's it, we found. The potential is going to be what, 0 at x is equal to 2 by 3, right? Somewhere here nearby the charge which is having less magnitude. Now what, one is this, suppose both the charges are of what, okay, one is this, one can be outside the charge which is having less magnitude. Let's see how. Suppose this is what, 2q, this is what, 4q, right? Minus 4q. Let's take here somewhere, right? This is what, 2, so this distance is going to be what, 2x. Okay, again K 2q by what, x is equal to k 2 plus of x, this one, right? K minus of 4q by what? 2 plus of x. Now let's see, right? So 2 plus of x minus of 2x, minus of 2x. So x is equal to what? 2 is equal to minus of this, right? Minus of 3x. So x is equal to minus of 2 by 3. That's it. That is what you can write. So by this way, yeah, distance again came in negative. Anything we did mistake here? It cannot be. That is what I was thinking. How it will be? That side we took, right? That side if you took, then it should be positive. This minor mistakes. So 2x, yes, correct. 2 plus x. Now 3x. Now x, this will come that side. So x is equal to what? X is equal to 2. So somewhere here, right? Somewhere here, this distance is what? 2. So from here to here, it becomes what? 4. Whatever. You guys understood now, right? Now we are going to see that what? One question which they asked in JEE Mains 2013. Let's see. Suppose I'll draw it. Now it is kind of a rod thing, right? And then at point O, we want to find what is the potential. Like it is uniformly charged, positive, positive, positive. It is uniformly charged. Now at point P, we want to find from here to here. And then we can say distance is L, right? And then we can say this distance is what? X. Okay. Why we took no, that we should not take now itself. What is the question here? That you are supposed to find potential due to this line charge, positive line charge at point P. Fine. And this distance is also L. This is also what? L. Now guys, the problem comes here is what? It is not a point charge now, right? It is an extended charge and everywhere charge is there, right? Uniformly charge is distributed. So if you want to find potential here, then you will have to find, see, if this is the wire, if this point you will take, then distance will be only L. But the same potential, same thing if you will take, this is L, at the end of the, suppose this is the wire. Now here charge is different, less charge will come. Now charge is increasing. If you will take here, it is increasing. Till here, it will increase too much. So potential is going to change, right? KQ by R, length will change, charges are changing. Of course, potential is also going to change. So it is better. What we'll have to do in this case is only one way we can go, that is integration. That take a small part, find potential for that, then what? Integrate from 0 to 2L or whatever. Then put the limits, you will get answer, right? So the same way here also we'll have to do is what? Now we can say take a small element, right? We can say we took a charge dq, right? Here linear charge density we learned, right? Linear charge density lambda. Lambda is equal to what? Charge per unit length, right? Charge per unit length. So dq dx. Let's take dq dx. So we can say here. Okay, leave first. Let's write this. We can say small potential is equal to k dq by what? K dq by because from here to here, right? All the way we'll have to go here. So we can say k dq by x. Okay. Now we cannot, we cannot do anything. Let's charge and x we cannot integrate, right? So what we'll have to do is charge we'll have to convert in the form of x. Fine. So we can say here, no, lambda is equal to dq by dx, right? So dq is equal to what? Lambda dx is equal to dq. Yes. So now we'll put there. So we can say now k lambda dx by what? X is equal to what? dv, right? Okay, k and lambda is what? Constant. Linear charge density, k will come out, dx by a, same integration, right? So we can say k lambda integration of what? dx by x is equal to what? dv integrated. Acha. From where to where? Now we can say L to what? To L, right? L to 2L. So now dx by x integration again, log base e to the power what? X, right? From where to where? L to what? 2L k lambda v, right? Okay, I am assuming that this integration you know, and you should know. There is no other go. So now we can say k lambda log, right? Log e to the x, right? Ex we already had done. So it is in division. So 2L by L. So 2 only, right? Is equal to what? V. So k lambda by what? Log e to the power 2. K is what? 1 by 4 pi epsilon. Lambda is what? Charge per unit length. Log e to the power 2 is equal to V. So this question they asked. Easy question was there, right? On the basis of this only they asked. So till here we will do in this class. Next lecture we will start from here itself. Till here you guys revise. Try to write the notes along with me, so it will be beneficial, more beneficial for you guys. Fine.